In this video, we're going to cover the ins and outs of sketching linear functions. For those who don't know me, my name is Chris Iannazoni. I used to work as an engineer for a defense company, and I've since left that to start a career in tutoring. I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. Before we look at how to sketch linear functions, it's worth understanding what a function even is. A function is just something that describes a relationship between one or more variables. For example, if I have the simple linear function y equals x plus 1, that's just a rule that tells me that the y value is always going to be one number larger than the x value. If I want to know the y value when x equals 0, then all I'm going to do is substitute x equals 0 into the equation and thus get y equals 1. This relationship can be plotted on an axis, where y is on the vertical axis and x is on the horizontal axis. So, if we know that x equals 0 and y equals 1, then we simply just draw a dot at the intersection of those two values. This is what's known as a coordinate. The coordinate is 0, 1. You write the x coordinate first and the y coordinate last. This also works backwards. For example, if I know that my y coordinate is 0, then I can figure out what the corresponding x coordinate is by substituting in y equals 0. When you rearrange for x, you're going to get x equals -1. Thus, the total coordinate is going to be -1, 0. Now that's just for coordinates, the individual points along a curve. The entire sketch of the curve depicts all the possible coordinate pairs, which for linear is found by just drawing a straight line that connects two points together. Let's have a look at that in more detail. We can sketch any linear function by following these steps. We'll start with finding the axes intercepts. Specifically, we're going to look at how to solve the x-axis intercepts. The x-axis intercept is just the point where the function touches the x-axis. The good news is that the y-coordinate at that point will always be 0, since the x-axis is the line y equals 0. Thus, if you want to solve for the x-intercept, all we're going to do is substitute y equals 0 and then solve for x. We can do a very similar thing for the y-intercept. This time we're going to sub in x equals 0 and solve for y. This has given us 2 points that we can put on the axes. All we've got to do from here is draw a straight line that goes through them. And just like that, we've finished the graph. So to summarize, we can sketch any linear function if all we know is the axes intercepts. We solve the x-intercept by setting y equals 0 and solving for x, and we solve the y-intercept by setting x equal to 0 and solving for y. Once we have those 2 points on our axes, we just draw a line connecting those points. Sometimes there will be 2 linear functions on the same graph, and you'll be asked to figure out the intersection point between those 2 lines. We actually use a similar strategy to solve this. The first thing to really hone in on is that if these functions are touching at a single point, then it means they have a point of intersection. This might sound like a no duh, but what it means is that they share an x and a y value at that point. This is important. The other thing to notice is the function itself. One of these functions is y equals 2x plus 4. Let's think about that for a second. That statement has an equal sign in it. That means that my value y is the same thing, is equal to 2x plus 4. So I could either say y, or I could say 2x plus 4, and be talking about the exact same thing. The same logic is true for the second equation. Instead of saying y, I could say -x plus 1. Those two things are identical. Now, let's put that all together. Both functions share a y value. That means that the y from the first equation is identical to the y from the second equation. But if y is equal to both 2x plus 4 and it's also equal to -x plus 1, then both of those things must also be equal. So we can equate those. This matters because now there's only one variable left in our equation, which we can solve for. We just rearrange for x. If you want to find the corresponding y coordinate, then you can substitute into either of the original equations since they both share a point. Doesn't matter which one you plug into, they both have that identical point. Once we have both the x and the y coordinate, we're just going to label that coordinate and then finish the question. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool, you should check it out. I'll see you there.